Notes number 9 is going to go through area of a sector again, but then also add in some simple probability with it. So remember that the section of a circle created by the central angle and two radii, so in our picture right here, this is called the sector. And the way we find the area of that sector is we take the portion out of 360, so 120 degrees out of 360. It's a portion of the area of a circle, so times pi r squared. So when we do simple probability, remember this is part out of a whole, so you have to figure out what piece you have out of the whole thing. We can either write it as a fraction or percentage, but most likely we're going to write it as a percentage for most of our answers. So an example, if we had 6 out of 10, that would be reduced down to 3 out of 5, or if we divide 3 divided by 5, we get 0.6. If we move our decimal over 2 places, that means it is 60%. So going on to number 1, if we want to find the area of our shaded sector, we need to take our degrees out of 360 and then multiply it by the area of a circle, so pi r squared. So our radius is 15, and I want you now to go through and figure out what is the area of that sector. And you can leave it in terms of pi. What you should have set up then was 120 over 360 times 225 pi. And you can multiply all of the top together. So we get 27,000 and then divide it by 360 and we get 70 pi. So there's your exact answer. If we want non-exact, then it would be 235.6 and it'd be millimeters squared since we're finding area. Now for the probability part of it, what is the probability of getting or being in the shaded part versus the whole circle? That means that we need to take the area of our shaded and divide it by the area of the circle. We already found the area of the shaded, and that's our 75 pi. The area of the circle, if we remember, up here, this pi r squared is the area of the circle. So when we found it right here, that is the area of the circle that we're going to use, so 225 pi. Now when you simplify it, notice the pi's are the same, so cancel those out. Divide the remaining part, and we get 1/3, or it's 0.33 repeating, so this would be 33% is how we're going to write our answer. Now number 2 is going to be the same thing, except we want the white sector section, so we want the area of all of this instead. So if we know that the whole degree around the outside is 360, if we subtract out the 131, we are left with 229 degrees. So we're going to take 229 divided by 360 times our pi r squared. So we get 144 pi times our 229 all over 360. If we multiply the top all together, that gives us, let's see, 32,976 pi over 360, and I'll reduce your fraction or divide it, and we get 91.6 pi. So there's our exact answer, and I type that in to multiply by pi, we get 287.8 meters squared. So that would be your non-exact answer. Now remember, for the probability part of it, we need to take the part divided by the whole. And we already know that the area of the circle is this 144 pi. The area of the white section we just found, so 91.6 pi. And now I want you to simplify that and tell me what percentage we are going to have of our circle. You should have crossed out the pi's. When you divide 91.6 divided by 144, we get 0.636 with a bunch of ones repeating. And when we move the decimal over 2 places, that gives us 63.6%. For this last one is a little challenging, and there's multiple steps, but each of the pieces individually is not that difficult, and we've done before. So we have a round pizza. It's cut into congruent sectors, so equal pieces, and each of the measures of each of the pieces of pizza are going to be 20 degrees. And we need to figure out how many pieces there are in the whole pizza. So remember that the number of degrees in the whole pizza will be 360 degrees divided by our 20 degrees, and we are left with 18 pieces. Next, for the probability of getting one slice out of our pizza, we need to figure out what is the chance of getting that one slice out of the whole pizza. So one slice of pizza will be just one, and there are 18 slices out of the pizza, so if we divide 1 out of 18, we get 0.055 repeating. So if we move the decimal over 2 places, we get 5 point, because it'd be repeating 5, so 5.56 or 5.6% is our probability of getting one piece. So the last question now is, what's the length of the pizza crust, so around the edges, in 5 slices when your diameter is 10 inches? So we need to figure out what the length of one of them will be, and then we can multiply that by our 5. Or we can just figure out what's the degrees of 5 slices, and then we can find the arc length of those. So if we have 5 slices of pizza and each of those are 20 degrees, that takes up 100 degrees in our pizza. So remember, the arc length is the degree divided by 360 times 2 pi r. So the degree is our 100 divided by 360 times 2 pi, and the radius, we know the diameter is 10, so that means the radius is going to be 5. So we get a 10 pi times 100 all over 360. So 1,000 will be on top once we multiply those, divided by 360. We can cross out one of the zeros or just reduce it all together, and we get a 25 over 9 pi, but that doesn't really tell us how many inches that is. So if you find the non-exact answer, that would be 8.7 inches is how long around the edge of our pizza it would be for 5 slices.